Date 2014 Civil Engineering Set 1 Question 28. A particle moves along a curve whose parametric equations are x equals t cube plus 2t, y equals minus 3 e power minus 2t, and z equals 2 sine 5t, where x, y, and z show variations of the distance covered by the particle in centimeter with time t in seconds. The magnitude of the acceleration of the particle at t equals 0 needs to be found in units of centimeter per second square. The relevant NPTEL reference has been cited. So, if we are given a fluid flow to be visualized in which a fluid particle is flowing, so it will have certain x, y, and z coordinates at every time instant t. So, to visualize this, if we have the x coordinate, y coordinate, and z coordinate, and we differentiate the position along x, we would get the velocity along the x direction. If we differentiate the position along y, we would get the velocity along y direction, and if we differentiate the z position, we would get the velocity along z direction. Once we differentiate it once more, that would give us the acceleration along the x direction. Differentiating y would give us acceleration along y, and differentiating the velocity in z direction would give us the acceleration in z direction. Once we know the accelerations along x, y, and z, the net acceleration can be found out as a net, which will be equal to the square root of ax square plus ay square plus az square, since ax, ay, and az will be at 90 degree to each other. So in this case we have been given x equals t cube plus 2t. So we will take the derivative of this. That would give us vx equals 3t square plus 2. We'll take its derivative once again. That would give us the acceleration along the x direction, which would be equal to 60. Next we have y, which is equal to minus 3 e power minus 2t. We'll take its derivative. That would give us the velocity in the y direction, which would be equal to 6 into e power minus 2t. Taking its derivative once again, we would be obtained by acceleration in the y direction, that would be minus 12 e power minus 2t. Then we have z, which is 2 sine of 5t. We will take its derivative. That would give us velocity along the z direction, which would be equal to 10 cos 5t. We will take its derivative. That would give us acceleration along the z direction, which would become minus 50 sine of 5t. Now it is given that we need to find the acceleration at the time instant t equals 0. So substituting t equals 0, ax would become 0, ay would become minus 12, and az would become 0. So a net would be equal to the square root of ax square plus ay square plus az square. This would become equal to 0 square plus minus 12 square plus 0 square, which would be equal to square root of 144. That would become 12 centimeter per second square. That is the net acceleration. So the magnitude of acceleration of the particle at t equals 0 is 12 centimeter per second square. The relevant NPTEL reference has been listed.